Okay, so we have another example, example 5, and there's nothing to multiply out in this problem, so we're just going to set it to 0. I'm going to take that negative 3a and I'm going to move it to the other side. It's going to become positive, and I need to put it in between the a squared and the constant, so it's going to look like this. 18a squared, it's going to be plus 33a minus 30. So that subtraction sign is with the 30. I always think of, like, whenever I have a term, I look in front of it to see if it's addition, if it's positive or if it's negative. If it's subtraction, that subtraction sign goes with the term behind it. And then when we brought this over, it became positive, and we want it in standard form. We want the a squared term, then the a term, then the constant, okay? And so we have it set equal to 0. Those are just some points I wanted to bring up that we hadn't maybe mentioned earlier. Okay, now how are we going to factor this? Well, it looks to me like there's a greatest common factor of 3. So I'm going to factor out of 3. Okay, now I have to try to factor the polynomial inside the parentheses. So I'm going to use the AC method. I'm going to go 6 times negative 10. So I want two numbers that multiply to be negative 60, but I want them to add to be 11. Now, once you get the hang of this AC method, I think you'll really like it. Students often prefer it, but it does take a little bit of getting used to. So practice the factoring and write it out. That'll help. Okay, so can we think of two things that multiply to be 60? Well, negative 60. So let's go 1 and 60, 2 and 30, 3 and 20. I'm going to have a long list this time. 4 and 15, and maybe not so long. 5 and 12, and 6 and 10. That's all the integers that go into 60. Now we want a negative 60, so one of them has to be negative. So the idea is, well, this is positive over here, so make the smaller number negative. Okay, so which one of those combinations adds up to 11? It's this one right here. So negative 4 and positive 15, that'll add up to 11. Okay. So I don't know if you got that, but you can stop the video and think about it for a minute if you want. All right, so here we go to write it. 3, that 3 was the greatest common factor. It's just out front there. And then I'm going to have the 6a squared minus 4a plus 15a, those were the two numbers I found, minus 10 equals 0. Okay, here comes my dotted line. And so this is where it gets a little bit trickier to write. You have the 3 out front, then you put a bracket, and now look at those two terms and factor out the greatest common factor. It's going to be 2a. And I'll have 3a minus 2. You can check the multiplication, but that's going to work. Plus, it's addition this time right there. And then look at these two back terms, and what do they have in common? A 5. And what do we have left if we take out a 5? 3a minus 2. And then the big question is that binomial the same as that binomial? It is, yay! Okay, so we get to continue our factoring, our grouping's working. That 3 is just still out front there. We'll talk about that 3 in a little bit. And then we're going to have a binomial of 3a minus 2 and a binomial of 2a plus 5. Okay. Now, when we factored, we have 3 factors here. We've got a factor of 3, a factor of 3a minus 2, and a factor of 2a plus 5. Those are the things that are being multiplied. But when I talked about the steps, I said, set each factor that has a variable equal to 0. This 3 right here, it's just a 3. It's not going to be 0. So it's not going to have a solution to it. So you can just kind of forget about that 3. Forget about it. Okay, anyway. So now we'll take the factors that have variables, 3a minus 2, and set that one equal to 0. And the other factor, 2a plus 5, and set that equal to 0. All right, so are solving these getting to be a little bit easier, these linear equations, hopefully. Little steps here, but you want to take your time, you want to get it right. Okay, so I think those are right. Double check my math as I was zipping through it. That looks good to me. Yeah, and you'll get to a point where you'll just see them, but okay, so we have two solutions. They do usually write the smaller one first, but I don't really care. Negative 5 over 2 and 2/3. So two solutions, and that's what we get.